Hey guys, this is Group 8's video lab report from Section 3. We formed the hypothesis that if the block has a higher kinetic energy at the bottom of the ramp, then the force of friction will be smaller, as indicated by the coefficient of friction of the surface. We found the average kinetic energy was determined by averaging the final velocity of each trial for the respective surface. The kinetic energy of the whiteboard was 5.19 times 10 to the negative 6 joules. The kinetic energy of the cardboard was 4.57 times 10 to the negative 6, and the sandpapers was 1.75 times 10 to the negative 6. The coefficient of friction for each surface were as follows. The block had a different final velocity and thus kinetic energy at the bottom of the ramp for each surface. The mass of the block, however, was so light and the length traveled and the angle were so small that no difference in coefficient of friction was determined. Thus, this lab produced inconclusive results. For this lab, we used 3 different surfaces in order to determine the relationship between frictional force and kinetic energy of an object. The main idea of the lab was to determine whether or not different frictional forces affect the kinetic energy of the object as it reaches the bottom of the ramp. Different frictional forces shown by different coefficients of friction are determined experimentally. First, we took a video of a wooden block sliding down 3 different surfaces. We used Tracker to track the block's motion and analyze the data using Excel by calculating the velocity and acceleration for the block. We also created graphs of position, velocity, and acceleration versus time using Excel. Here's a list of the materials used and a description of the procedure.
So these are sources of error, and one is that the camera angle could have been moved for every trial, and the solution is listed below. And another source of error is that the cardboard surface had a dent near the bottom, so the data collected near the end of those trials may have been affected. The solution for that is also below. So these are the models we used in our lab. We used kinetic energy, resistive force, and work. Kinetic energy is the energy of a body or a system with respect to the motion of the body or of the particles in the system. Resistive force resists motion and acts in a direction opposite of any motion or applied force. Since the change in kinetic energy is equal to the force times distance because both are equivalent to work, we can see that the force directly affects the kinetic energy of the object. The frictional force is in the opposite direction of the block's motion down the ramp, represented as a negative value in net force calculations. These are the graphs showing the results for the whiteboard trial 3. The graphs shown here are for trial 3 using the cardboard surface.
These are the graphs for trial 2 of the sandpaper surface. This slide shows our variable manipulation. We began with kinetic energy. Work is then defined as the change of kinetic energy which is equal to F net times displacement. Net force is determined in the x direction, which we defined as along the ramp. Using work, changing kinetic energy can be equated to F net times delta x. Finally, the free body diagram shown to the left was used to replace variables such as normal force using trig functions. After variable manipulation and substitution, mu equals mg sine theta times delta x minus change in kinetic energy divided by delta x times mg cosine theta. These are the calculations for the whiteboard using the variable manipulation shown previously. In the end, the coefficient of friction was determined to be 0.9004. These are the calculations for cardboard. In the end, the coefficient of friction was determined to also be 0.9004. These are the calculations for the sandpaper. The coefficient of friction was determined to be 0.9004. Because all values of mu for sandpaper, cardboard, and whiteboard were shown to be 0.9004, it's shown that this lab was inconclusive.